Okay, so here we have the Unit 6 review that we are working on in class, and this is in preparation for the Unit 6 test coming up. So the first two questions here are just simple proportions, and we can solve by cross-multiplying. So I set this up by doing 9 times n minus 1 equals 3 times 2n plus 9. Here I'm going to have 9n minus 9 equals 6n plus 27. Make sure to distribute so that both terms get multiplied. And I can subtract the 6n from both sides. So on the left I get 3n. If I add 9 to both sides I get 36. So n is equal to 12. Very nice. What I didn't do for this one, 3 to 9 is actually 1 to 3. So we can actually reduce these fractions. So 8 to 10, they both have a common factor of 2, so I could say that's 4 to 5, and that reduces. So now when I cross multiply, it's a little bit easier. So I'm going to have 5 times x plus 9 equals 4 times 7x plus 2. So I distribute, so I get 5x plus 45 equals 28x plus 8. So I could subtract the 5x from both sides, so I get 23x is equal to, if I subtract the 8 from both sides, 37. Divide by 23, so I get x is equal to 37 over 23. No need to put that in a calculator and get a decimal. Leaving it as that fraction is fine. All right, and the next two questions are solving for x, and it's given that the triangles presented are similar. So that means we can just go right in and set up a proportion. For 3, it tells us that STU is similar to SKJ. So that means that side TU, which is 40, must correspond to KJ. So that's going to give me 40 to 1 plus 2x equals 24 to 9. And again, 24 and 9, they both have a common factor of 3. So if I wanted to, I could reduce to 8 over 3. So actually, why don't I go ahead and do that? So 40 over 1 plus 2x equals 8 to 3. So now when I cross multiply, I'm going to have 8 plus 16x equals 120. Subtract the 8 from both sides, so I get 16x is equal to 112. And 112 divided by 16 is going to leave me with just 7. All right, next up we have, well, they don't actually tell us that the triangles, which triangles are similar, but we can see that there are overlapping triangles. So we have this one there, and we have this larger one. Sometimes it may help to write these out as two different triangles, so redraw the picture. And so I don't need to do that here because we can set up a proportion really nice. We have these sides 13 and 14. We don't really need that. Actually, sorry, we do. We do need this 13. It's this 84 we don't need. Actually, no. Sorry, I'm misspoken. We could use the 84 or the 14. They're basically giving us more options than we need. You can see these two triangles are similar by side, side, side. But what I'm cluing in on is this right here. So this 42 and 7, that's nice and it's away from this mess. So I can actually set up that and I can say, all right, well, 42 from the big triangle is proportional to 7 on the other triangle. So that corresponds to 7x minus 6 on the big triangle to 13 on the small triangle. So we can see on the big triangle we have 42, small triangle 7. Big triangle 7x minus 6, small triangle 13. Again, a beautiful thing about 42 over 7, that's actually 6 over 1. So multiplying here is going to be really nice. 6 times 13, that's going to be 78. So I get 78 equals 7x minus 6. When I add the 6 to both sides, I get 84 is equal to 7x. And if I divide that by 7, I get that x is equal to 12. So really nice. There are a few different ways to go about that, but that's just the one I preferred. All right, here, state if the triangles are similar in each pair or not. Okay, so for number 5, remember there are three theorems: side, 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 angle, and angle, angle. With number 5, we don't have 3 sides, so it can't be side, side, side. No angles are listed, so maybe not angle, angle. But we see that there are 2 sides. Maybe there's an angle? Oh yeah, this angle right here. The vertical angles are always congruent. So there's our congruent angles. We just need to show that the sides are proportional. So if you can kind of see, this triangle here, if you rotate it around, would fit right on top of the other one. So that means that 10 to 79 should equal 12 to 96. So let's figure that out. Well, 10 divided by 79, if you put that in your calculator, that's just going to be 0.1266 about. And 12 divided by 96, however, that's actually 0.125. That's actually 1/8. You can see that these are not the same. If this were 80, then it'd be 1/8 equals 1/8. But it's not. So these are actually not similar. And we can show that by the 2 proportions. So don't just see that you have 2 sides and an angle and say, oh, side, angle, side, they're similar, because they're not. You have to actually show that the proportions work out. And in this case, they don't. Number 6 is beautiful. You have parallel lines. So you have corresponding angles there that are congruent, and these 2 corresponding angles are congruent. So what that gives you are angle, angle. So if we have U, V, W, that's going to correspond to triangle UKL, and this is all because of angle, angle. That's all you really need to explain. Right down here, we're solving again for x. This is that mid-segment theorem, so 2 times this mid-segment is going to equal this side. So we can say 2 times x minus 1 equals x plus 6. So we're going to have 2x minus 2 equals x plus 6. So we subtract x from both sides, we get x equals 8. Done. And actually the same deal over here. So this is going to be 2 times 2x minus 6, and that's going to equal x plus 6. So we distribute this in, so we get 4x minus 12 equals x plus 6. So we get 3x is equal to 18. X is equal to 6. Beautiful problem there. Yeah, so this is just that nice theorem. It makes it really easy when you know the theorem, and you can do that work. All right, so for these, the tricky part with this is knowing the theorem to set up, but also this side length. If the whole side length is 5x minus 2, and this portion is 10, then this is going to be 5x minus 2 minus 10. Right? It's the whole side minus what we already have. Well, we can combine those to negative 12, so this is going to be 5x minus 12. So when we set up proportions, remember it's side to side, segment to segment. So for this, it's going to be 16 to 20 equals 5x minus 12 to 10. 16 to 20, they both have a common factor of 4, so I can reduce that to 4 to 5. Makes my multiplication later on a little bit easier. 4 times 10 gives me 40, and I cross multiply, so I get 25x minus 60. Add the 60 to both sides, so I get 100 is equal to 25x. Divide by 25 to get x is equal to 4. Same principle with number 10. If the whole side is 6x minus 3 and this segment is 15, the remaining side, or the remaining segment, must be 6x minus 3 minus 15. So this right here is going to be 6x minus 18. Remember, combining your like terms. And so the proportion we can set up is side to side. So 8 to 20 equals 6x minus 18 to 15. 8 to 20 both have a common factor of 4, so we can reduce that to 2 to 5 equals 6x minus 18 over 15. Cross multiply to get 30 is equal to 30x minus 18 times 5, which is 90. Add the 90 to both sides, we get 120 is equal to 30x. So x is equal to 4. Nice. That's a tricky theorem, so just make sure you get lots of practice with it. It's very easy to confuse it with the other theorems. And these, the last two questions. Again, just stating if the triangles are similar or not, and then completing the similarity statement. So it looks like they give us all three sides, so we could probably use side, side, side here. This whole length is 40. This is 32. So 40 minus 32 is going to give us 8. So we can see that 8 to 40 corresponds very nicely. That's going to be the same as 9 to this whole distance here, which is 36 plus 9, which is 45. It's 9 to 45. And that's going to equal this whole distance there, 10 to 50. So you can put these in your calculator, but you should be able to reduce and see these fractions. 10 over 50, that's just 1 over 5. 9 over 45, again, 1 over 5. And 8 over 40 is, again, 1 over 5. These proportions hold true, so side, side, side is true. So if I have triangle MLK, that's going to be similar to triangle MUV. MUV. And it looks like number 12, again, they give you three sides, so stick with the three sides. Careful with the orientation. It looks to me like maybe 36 goes with 63. So we can say, all right, 36 to 63, that's going to equal, if I'm going from bottom to top, 36 to 63 equals 52 to 84 equals 48 to 91. So this one, we can reduce, we can play around with the different decimals to get a reduced fraction, or you can put it into your calculator. Well, what can we do? They both have, these here, they both have a common factor of 9. So we could say that's 4 to 7. 84 and 52. They both have a common factor of 12. No, they don't. Well, I'll tell you what. Let's not worry about these fractions. Let's just get these decimals. So I did it the other way for the last one. So 36 divided by 63, that will give us a 0.571. 52 divided by 84 is different. So these actually, this is not set up correctly apparently, because these should work. So this is actually a tricky one. So if you did struggle with this, I'm actually going to say don't worry too much, because it's a little bit tricky to see how the sides go into play. So I would actually say I don't like this question. So I would not give you something like this on a test, because actually we need to rotate these. So we can see that 84 is going to correspond with 48, which means, so top to bottom, which means that 91 is going to correspond to 52, which means that 63 will correspond to 36. So let's again try this. So 84 divided by 48, that's 1.75. 91 divided by 52, 1.75. And 63 divided by 36 gives us 1.75. Okay, beautiful. So that's side, side, side. So again, because I had to rotate that, these more or less look like isosceles triangles, so that's why I had a question about which sides corresponded to which. So just be careful of that. Now, to write the congruence, or write the similarity statement, if you set up these proportions correctly, you can follow through with them. So 84 is this FG. So FG. 48 is ST. So that's going to be ST. GH is the 63. And we said that corresponds to 36. All right, so ignore what I just said there. That should be TSR. So FGH corresponds to, TSR, because you have to rotate and flip around. So this was a hard one. So if you got this, number 12, fantastic, great, feel good about yourself. If you didn't, don't necessarily feel bad about yourself. This was a tricky one, again, because you have to rotate this, and it's very difficult to see which sides actually correspond. It's very unlikely I will give you this on a test. So if you understand the concept of what proportions to set up, then you're in good position for success. So let me know if you have any questions.